Hello students, in the previous video we have discussed about the reactions of dilute sulfuric acid, and in this video we are going to see the reactions of concentrated sulfuric acid. So come, let's understand. Concentrated sulfuric acid undergoes three important kinds of reactions. The first one is the oxidizing reactions. It undergoes oxidation reactions. In other words, it oxidizes other substances. Concentrated sulfuric acid decomposes to give nascent oxygen. Now, this reaction is what is responsible for oxidation. So, it can oxidize metals as well as non-metals. Under metals, in our syllabus, we have only copper. So, copper is oxidized to copper 2 sulfate. Sulfur dioxide gas is evolved. So, the observation will be blue solution is formed. Copper sulfate is a blue solution formed, and colorless gas with pungent odor evolved, which is sulfur dioxide. The gas turns potassium dichromate paper green. So it is, we have already seen under dilute acid also, the potassium dichromate paper turning green is the test for sulfur dioxide gas. Okay, so let's write the reaction. Copper Cu plus H2SO4, which is concentrated here, will give you CuSO4, copper 2 sulfate, and water and sulfur dioxide. So how do you balance it? 2H2SO4 and 2H2O, sulfur dioxide. That's it. So it is balanced, right? Now we have non-metals. Under non-metals, we have carbon, which is oxidized to carbon dioxide, sulfur, which is oxidized to sulfuric acid. First, sulfur dioxide is formed, which will change to sulfuric acid because water also is present in the medium. Let's see the reactions of these. The non-metals, carbon and sulfur reacting with the concentrated sulfuric acid. Carbon plus concentrated sulfuric acid will give you CO2 plus H2O plus SO2. Okay, so 2H2O and CO2 and 2H2SO1, 2H2O and 2SO2. Okay, so this is how it is balanced. Sulfur dioxide is also produced along with the carbon dioxide. Sulfur is oxidized to sulfuric acid. Okay, so you get H2SO4 plus H2O. Okay, so sulfur plus 2H2SO4 will give you H2SO4. No, sulfur dioxide is formed. Sulfur is oxidized to sulfur dioxide, SO3, SO2 plus H2O. So we have 2H2SO4, so 3 SO2 is coming. 1 SO2 from this sulfur and 2 from the acid. So 3 SO2 plus 2 H2O. Okay, right. So this is how the reaction takes place. Sulfur dioxide, not sulfuric acid. Sulfur dioxide is produced and water is produced. Then we have dehydrating reactions. The reactions where concentrated sulfuric acid removes chemically combined water. Dehydrating agent removes chemically combined water from other substances. So this reaction we can see cane sugar. Example, sucrose is dehydrated to carbon, and also we have copper sulfate being dehydrated. So the first one, cane sugar, otherwise chemically known as sucrose, is dehydrated. The white crystals of sugar, it is the sugar that we use at home, common sugar, which is known as sucrose or cane sugar. It gets charred and a black spongy mass is left behind. C12H22O11, this is sucrose. Okay, sucrose. When corn H2SO4 is added to it, what happens is changes to 12 atoms of carbon and 11 H2O. So water will be removed as vapor because it will go out because of the temperature produced, and the black spongy mass is the 12 atoms of carbon. Black spongy mass is produced. So sugar changing, burning to carbon, that is known as charring, charred to black spongy mass. Then we have hydrated copper 2 sulfate, which is a blue color crystal, in other words known as copper sulfate 5 water, which is dehydrated, changes to white amorphous substance. Blue crystalline substance changes to white amorphous substance. CuSO4.5H2O is the crystalline copper sulfate. When corn H2SO4 is added to it, it changes to CuSO4. And 5 molecules of water is removed from there, which will be eliminated or absorbed by corn sulfuric acid. This is white amorphous, or you can say powder. And this is blue crystals. Okay, so this is another example of dehydration reaction. The third reaction that sulfuric acid gives is the non-volatile nature. Concentrated sulfuric acid is a non-volatile acid. Non-volatile means does not give its vapor at ordinary temperatures or easily. It has a high boiling point of 337 degrees Celsius. So this is high because the other acids, other two strong acids are hydrochloric and nitric acid. They have their boiling points around 85 and 83. So this is very low, whereas so they are volatile acids. So corn sulfuric acid having such a high boiling point is known as non-volatile acid. So it can displace volatile acids from their salts. So these salts are ionic compounds. When corn sulfuric acid is heated with it, it does not vaporize out. It will stay in the medium and it will react. So NaCl, we have already learned these reactions. Below 200 degrees Celsius will give you NaHSO4 and HCl. The acid HCl is liberated to NaCl, and above 200 degrees Celsius you will have Na2SO4 and 2HCl coming up, right? KCl similarly below 200 degrees Celsius will give you KHSO4 plus HCl, and 2 KCl if you take and above 200 degrees Celsius will give you K2SO4 plus 2 HCl. Okay. Similarly, the nitrates will give nitric acid. So NaNO3 plus H2SO4 less than 200 degrees Celsius will give you NaHSO4, sodium hydrogen sulfate, and HNO3, nitric acid is produced. 2 NaNO3 will be required when you heat to higher temperatures. So it will give you Na2SO4 plus HNO3. 2 NaNO3, H2SO4, Na2SO4 and 2 HNO3 will be produced. Now if you take KNO3 below 200 degrees Celsius will give you KHSO4 plus HNO3, and above 200 if you take 2 moles of KNO3 will be used, so you get K2SO4 and 2 HNO3. So these reactions are displacement reaction, displacement of the volatile acids from their salts using the non-volatile acids. So this is the non-volatile nature of sulfuric acid that we can see. So that's all in the reactions of concentrated sulfuric acid. So students, I hope you understood the reactions of concentrated sulfuric acid. So thank you for watching. If you have questions, please write in the comments.